Have you ever wondered what's really going on when your phone unlocks just by looking at you? Or how a photo app can instantly find every picture you've ever taken of your cat? Well, today we're pulling back the curtain on that exact technology, AI image recognition. We're going to find out how a machine actually learns to see.
Now, seriously, think about it. How does a piece of hardware and software look at an image and know, without a doubt, that it's you? It feels like magic, but it's not. It's actually a brilliant process of calculation and pattern matching. So let's break down exactly how it works, step by step. Okay, the first thing we have to get our heads around is that an AI doesn't see things the way you and I do. When we see a face, our brains use intuition, memory, and context. An AI, it just sees data, pure numbers. It performs millions, sometimes billions of calculations to find patterns. So it's less like seeing and more like being an unbelievably fast mathematician. To really understand this, we're going to walk through it like a training guide. We're going to use a simple 5-step process that explains how an AI goes from a total blank slate to a machine that can recognize almost anything in a picture.
Here's our roadmap. It all starts with turning pixels into numbers. Then the AI finds basic features. After that, it uses something called a neural network, trains on tons of data, and finally, it makes a prediction. So let's dive into step 1.
First up, we've got to talk about the absolute foundation of all of this. Before an AI can do anything at all, it has to translate what we see as a colorful image into the only language it understands, the language of numbers.
Everything, and I mean everything, starts with the pixel. You can think of a pixel as the single atom of a digital image. It's the tiniest possible dot of color. Every single picture you've ever seen on a screen is made up of millions of these little dots. And here's the crucial part. Each one has a number that represents its exact color.
A really easy way to picture this is to imagine that every image is just a giant sheet of graph paper. Each tiny square on that grid is one pixel, filled with a single, solid color. To a computer, a beautiful landscape photo isn't a landscape at all. It's just a massive grid of colored blocks.
And this right here, this is what the computer actually sees. Not a picture of a cat or a car, but a huge matrix of numbers. Each number in the grid represents the color and brightness for one specific pixel. This grid of numbers is the raw material, the starting point for everything that's about to happen.
So the AI has a giant spreadsheet of numbers. Now what? Well, a list of numbers is pretty useless by itself. The next step is to start making sense of it by finding basic patterns, or what engineers call features.
The AI scans this grid of numbers, and it's looking for simple things. For instance, a sharp change in numbers from one pixel to the next, that's probably an edge. A big area where all the numbers are similar, that's a block of color. To find a face, it isn't looking for a face. It's looking for the basic components, 2 oval-like shapes, a vertical line, a horizontal line below that. It's building a complex idea from very simple pieces. Okay, so the AI has found its basic features, all these little lines and shapes. Now we get to the most important part, the learning. How does it learn to assemble those simple pieces into something meaningful? This happens with 2 key ingredients, a digital brain and a massive, massive diet of data.
Let's meet the brain of the operation. It's called a neural network. It's a really complex system that's actually designed to mimic the way neurons connect in our own brains. Its whole job is to take all those simple features, the edges, colors, and shapes, and start piecing them together, layer by layer, to find more complex patterns.
But a brain is pretty useless without experience, right? That's where training data comes in. To teach an AI what a cat is, you don't show it one cat picture. You show it millions of them. And just as important, you show it millions of pictures of things that are not cats. With every single image it sees, the neural network adjusts itself just a tiny bit, getting better and better at recognizing the specific patterns that scream, cat.
You know, a fantastic way to think about this whole learning process is to imagine that the AI is solving a giant jigsaw puzzle, but it has never seen the picture on the front of the box.
And this is a perfect analogy for how it works. First, the AI finds all the straight edge pieces. For the AI, those are its basic features. Then it starts grouping pieces with similar colors and textures together, just like we would. That's pattern recognition. Finally, once it has grouped enough patterns, it can start to see what the final picture actually is, and that is the prediction.
And that brings us to the final step. After all of that training, all of that pattern matching, the AI is finally ready to look at a brand new image, one it has never seen before in its life, and make a highly educated guess.
So when you show it a new photo, it runs that picture through the whole process again. It turns it into numbers, finds the features, and then feeds those features through its fully trained neural network. The network doesn't just say cat, it spits out a probability. It might say, I am 98% confident that the patterns in this image match the patterns I've learned for the label cat.
So, that's the 5-step process. But this isn't just some theory in a computer lab. This exact system is running in the background of our daily lives, in places in ways you probably don't even think about. Your phone's face unlock is the classic example, of course, but this is also what allows a self-driving car to tell the difference between a stop sign and a pedestrian. It's what powers those apps that let you scan a product to find it online. And maybe most importantly, this technology is being used in medicine to help doctors spot tumors in X-rays and MRIs with amazing accuracy.
But, and this is a really big but, as powerful as all this is, it is not perfect. The system can make mistakes. It does make mistakes. And understanding why it fails is just as important as knowing how it works.
So what throws it off? Well, if an image is blurry or the lighting is just really weird, the numerical patterns can get all mixed up, and that can lead to a wrong guess. But the biggest factor of all is the training data itself. If an AI was only ever trained on pictures of one type of thing, it will struggle to recognize others. If its training data is limited or biased, its ability to see the world will be just as biased.
So if you take just one thing away today, let it be this. AI vision isn't really sight. It is a purely mathematical process. It's about converting images into numbers, finding patterns in those numbers, and then making a highly educated guess based on the millions of examples it's already seen.
And that leaves us with a final, pretty deep thought to chew on. This whole amazing system is built entirely on the data that we feed it. So the question becomes, if an AI learns from our data, what flaws, what imperfections, and what biases are we unintentionally teaching it to see in our world?